Alright guys, welcome to the Algebra 2K review for absolute values. Let's get started off on part 1. So number 1 says write the absolute value equation with the described transformations, and they provided us the parent function y equals the absolute value of x. So for number 1, vertical translation down, that would be y equals the absolute value of x minus 4. Reflection over the x-axis would be y equals negative absolute value x. Horizontal dilation, compression by 1/3. Right, that would be y equals absolute value 3x. Right, so the 3 is on the inside, it acts as the b value. Remember, everything on the inside affects the graph in the horizontal direction. Right, so then number 4, horizontal translation right 3, y equals the absolute value of x minus 3. So again, the inside is inside, horizontal, opposite domain. And then outside is outside, vertical, exact, and range. Right, so the inside always treat like the opposite when it comes to transformations and getting the vertex. Alright, so then for number 5, vertical dilation, compression by 1/3. Alright, so this is vertical, so we know that's going to be outside the absolute value. That is going to be y equals 1/2 absolute value x. Alright, so now part 2. Graphing transformations of y equals absolute value of x. Sketch the graph indicated by the transformations. State the domain and range in interval notation. Alright, so for number 6, by looking at the function, I know this is going to go left 2. And looking at the h and k of the function, this vertex would be at 0, -2. So let's put that on the graph, 0, -2. Oh wait, sorry, that is incorrect. That should be -2 parentheses 0. Alright, so -2 parentheses 0, so the h is telling us to go left 2, and then we don't have a k, so 0 for the k. Alright, so we go left 2, so -2, 0 for the vertex, and then, so when you graph these functions, get at least 5 points on the graph. Don't just put the vertex and then just draw your lines. Alright, so we have -2, 0. Alright, so if I plug in -1, we get back -1, 1. If I plug in 0, we get 2. If I plug in -3, 1, -4, -2. Alright, since we don't have an expansion or compression, you could just follow the pattern. You could just go right 1, up 1, right 1, up 1, and then left 1, up 1, left 1, up 1 on the other, and go in the other direction. Alright, so then this would be our function. And then for absolute value functions, the domain is always -infinity to infinity. And then for the range, which is read from bottom up, we start at 0 and then keep going up to infinity. So bracket 0 to infinity. Alright, so for number 7, absolute value of x plus 6. This one has a transformation of down 6. So that means the vertex would be at 0, 6. Oop, messed that up again. My bad. This should be up 6, 0, 6. Alright, so we're going up 6, so the vertex is at 0, 6. And then again, we don't have any vertical compressions or vertical expansions, so I could just follow this pattern. I could go right 1, up 1, right 1, up 1, right 1, up 1. Alright, so that would be our transformation in our graph. So we went up 6, and this is the graph for it. And then again, the domain is always negative infinity to infinity. And then the range here, since we went up 6, it would be bracket 6, and it's going up to infinity. Alright, so then for number 8, we have y equals 2 absolute value of x. Since we have a 2 on the outside at the very front, that's acting as our a value. This is a vertical expansion by 2. Alright, so vertical expansion by 2 makes the graph a little bit more narrow. Alright, so since we don't have an h and a k, the vertex is going to be at 0, 0. Alright, so 0, 0. Alright, so if we start at 1, the absolute value of 1 is 1, times 2 is 2. The absolute value of 2 is 2, and then 2 times 2 is 4. And then at 3, you get the absolute value of 3 is still 3, then times 2 is 6. That's a vertical expansion by 2. Everything should be expanding up by 2. And then the graph is symmetrical, so it's just symmetrical points on the left and right. And so that would be our function. And again, this is a little bit more narrow compared to the parent function. The parent function would look like this. Alright, so then for the domain, that would be negative infinity to infinity. And then for the range, bracket 0 to infinity. Alright, so that's 6, 7, and 8. Alright, so let's continue graphing with number 9. This one has the 3 on the inside. This would be a horizontal. So if it was on the outside, you would say vertical expansion by 3, but since it's on the inside, do the complete opposite. So opposite of vertical would be horizontal. Opposite of expansion would be a compression. And then the reciprocal of 3 is 1/3, so horizontal compression by 1/3. Alright, so then this one doesn't move left, right, up, or down, so the vertex would just be at 0, 0. Alright, so horizontal compression by 1/3. So everything's being compressed in. Alright, so let's see what we get for the first point. So if I plug in 1, we get 1 times 3, which is 3. The absolute value of 3 is still 3. If I plug in 2, you get 6. Absolute value of 6 is still 6. And if I plug in 3, we get 9. Right, so then our domain is from negative infinity to infinity, and the range is from bracket 0 to infinity. Alright, so then for number 10, y equals negative absolute value x minus 4 plus 3. Alright, so this one has an h and a k. The vertex would be at positive 4, comma, positive 3. So let's put it on my graph. Vertex of 4, positive 3. Alright, so it's also telling us, or the function is telling us that we're going to go right 4, up 3, and then also this negative in the very front. That is telling us that we have a reflection over the x-axis. Right, so that's going to make the graph flip upside down. Right, since I know the graph is going to go upside down, again, I don't have any expansions or compressions. I could just follow the same pattern, but this time go down. So instead of going right one, up one, I would go right one, down one, right one, down one, right one, down one. All right, and again, you could always just check your points using the calculator. Domain is still going to be the same, negative infinity to infinity. All right, so it's always negative infinity to infinity for domain. And then for the range, since the graph is upside down, we start off in negative infinity, and then as you move your way up, you stop at positive 3. All right, so the range is from negative infinity to 3 because it's upside down. All right, so now for number 11. So let's put a star by number 11. All right, for number 11, if you just look at the function, you would think that the vertex would be at negative 5 over 2, comma, negative 7. All right, but let's graph this and see how it looks. All right, so we have 3 to get the absolute value. It's math, num, abs. We got 1/2 x plus, all right, let's use alpha y equals. All right, so we got 1/2 x plus 5 over 2, then minus 7. All right, so if I graph this, we can see that the vertex is going to be at negative 5, negative 7. So not negative 5 over 2, comma, negative 7. So let's see why that happens. So the reason this happens is because this isn't in the correct format for the function. We have 1/2 x plus 5 over 2. So in this format, they already kind of distributed the b value. So we have to distribute the b value out so we can get the transformations and the vertex. So if I factor out 1/2 from this from the inside, we get y equals 3, the absolute value of 1/2. All right, so I just factored out the 1/2. If I factor out a half, I'm left with x, and then 5/2. If I take out a factor of a half, I'm just left with plus 5, and then minus 7. Right, so now I could see the transformations and the vertex. All right, so the vertex would be at negative 5, negative 7. All right, so we're going left 5, down 7. Here we have a vertical compression by 3. We have a horizontal expansion by 2. All right, so let me get the points from the table. So I already graphed the function. All right, so here's the vertex, negative 5, negative 7. I have a point at negative 3, negative 4. Right, I have another point at negative 1, negative 1. Then let's see, so it should be the same points going the other direction. So then negative 5, oh, that's a vertex. Negative 7, negative 4. And then we got negative 9, negative 1. All right, so then if I go in, let's see. Right here we get these points also. So where will we at? -1. Here at -4 we got -5.5. Alright, so that would be the graph for the function. Then for the domain, still -infinity to infinity. The range would be from bracket -7 to infinity. Alright, so now for 12 through 15, we're just describing the transformations. So first one, we have -5 absolute value x minus 7. Alright, so this -5 is telling you two different things. The first thing is telling us we have a reflection over the x-axis. We have a vertical expansion by 5, and the -7 at the end is telling us we're going to move down 7. Alright, for this one, be careful. We have 2x plus 6. Again, this is not in the correct format. We have to factor out the 2. So when I factor out the 2, we get the absolute value of 2 parentheses x plus 3. Alright, so our two transformations are horizontal compression by 1/2 and left 3. Alright, so horizontal compression by 1/2 and left 3. Alright, so the vertex for that one should be at -3, 0. Again, if you want to check, if I plug in the function the way it is, you could see that the vertex would be at -3, 0. Alright, so the same thing happens on number 14. We have to factor out this 1/4. So if I factor out the 1/4, we get y equals 1/2 absolute value 1/4 parentheses x. And then if I take out a factor of a fourth from -2, you're going to be left with -8. Right, so we have a vertical compression by 1/2, horizontal expansion by 4, and then the graph is moving right 8. Alright, so this one should have a vertex at 8, 0. Alright, and then for number 15, this one's in the format that we wanted. We have the A, we have a B, we have an H and a K. The A value is telling us vertical expansion by 3. We have a horizontal expansion by 2. The graph is moving left 5.
Good morning, Bridgem staff, and thank you so much for being here on today's workday. Just a quick reminder, we will be having mandatory training at 10:30. If you are unable to make it, please let me know so we can arrange another time. But we will be having training in the cafeteria at 10:30 today. Lunch will be provided sometime after 11:30, but before noon. So we're having Carrabba's deliver our lunch between 11:30 and noon. Thank you so much, and see you at 10:30.
Alright, so we're going left 5 and then down 7. Alright, so now let's go to number 16. So let's go to the solving. Alright, so for number 16, we have the absolute value of 5x minus 8 minus 27 equals 0. Alright, step number 1, get the absolute value by itself on one side. So get the absolute value isolated. So if I want to get the absolute value isolated, I have to add 27 to both sides. Alright, so now we have the absolute value of 5x minus 8 equals 27. Now we can make our two different cases. So case 1 is 5x minus 8 equals 27. The negative case is negative parentheses 5x minus 8 equals 27. Alright, so for the first case, we're going to add 8. We get 35. Divide the 5, you get 7. Second case, distribute the negative. Right, then subtract the 8. Then divide by negative 5, we get negative 19 over 5. Alright, so then very last step, once you find your two solutions, just make sure that they work. So I'm going to plug them into this function right here, or this equation, and just make sure that it gives me back a 27. So if I plug in 7, 5 times 7 is 35, minus 8 is 27, absolute value of 27 is 27, so that works. Alright, next one, negative 19 over 5 times 5 is negative 19, minus 8 is negative 27. The absolute value of negative 27 is 27, so that works. Alright, so then for number 17, again, get the absolute value isolated, so subtract the 7 first. Alright, then make your two scenarios. We have 2x minus 9 equals 4x minus 3. Then distribute the negative. Alright, so I'll just put negative parentheses 2x minus 9 equals 4x minus 3. Alright, so then for this one I'm going to subtract 2x on both sides. And I'm going to add 3. So I end up with negative 6 equals 2x, so x equals negative 3. Alright, second case, distribute the negative. You get negative 2x plus 9 equals 4x minus 3. Alright, for this one I'm going to add the 2x, add the 3. So we get 12 equals 6x. So after you divide the 6, you get x equals 2. Alright, so then let's just make sure that they both work. Let's plug them back in. Alright, so if I plug in, so we have to plug in, let's start off with the negative 3. Plug in negative 3 into both of these for x. So on the left side, 2 times negative 3 is negative 6, minus 9 is negative 15. Take the absolute value of that, you get positive 15. So this is going to be 15. And then 4 times negative 3 is negative 12. Minus 3 is negative 15. So since this is 15, this one's negative 15, that is telling me that negative 3 is extraneous. It's not going to work. If I plug in 2, right, 2 times 2 is 4, minus 9 is negative 5, absolute value is positive 5. 4 times 2 is 8, minus 3 is 5, so since 5 equals 5, that one works. Right, so then number 18, this one, the absolute value is already isolated, so I could just go ahead and make my two cases. 3x minus 5 equals 2x. Negative parentheses 3x minus 5 equals 2x. Alright, so then for the first case, I am going to subtract 2x. I get x minus 5 equals 0, so x equals 5. Alright, so then for the second case, distribute the negative. For this one, I'm going to add 3x. So I get 5 equals 5x, and then once you divide the 5, that's going to give you x equals 1. Alright, so then let's just make sure that they both work. Alright, 2 times 5 is 10, so we have a 10 on the right side. 5 times 3 is 15, minus 5 is 10. Absolute value of 10 is 10. So when x is 5, that works because 10 equals 10. If I plug in 1, 2 times 1 is 2. And then 3 times 1 is 3, minus 5 is negative 2. Absolute value is positive 2, so that one also works. Alright, so now we're on to the very last page. So number 19, we are solving inequalities, then we're going to graph the solution set. So for number 19, we have the absolute value of 7x plus 14 is greater than or equal to 35. Alright, so it's already isolated for us, the absolute value is, so then just make your two cases. 7x plus 14 is greater than or equal to 35. Negative parentheses, 7x plus 14 is greater than or equal to 35. Alright, so then for the first case, subtract the 14. 35 minus 14, that is 21, and then divide by 7, you get 3. So x is greater than or equal to 3. Alright, so then for the second case, distribute your negative. Negative 7x minus 14 is greater than or equal to 35. Add your 14 to the other side, you get 49. So 49. And then divide by negative 7. Alright, so this is important. When you divide by a negative number, the sign flips. So x is less than or equal to negative 7. Alright, so then let's put this on the number line. Alright, so negative 7 and 3. Remember to put these in numeric order from left to right. And then they both have closed dots. Alright, so then all the x values greater than or equal to negative 3 are on the right side. All the x values less than or equal to negative 7 are on the left side. Alright, so in interval notation form, we would write this as negative infinity to negative 7, bracket, union, open up with a bracket again, 3 to infinity. And again, we're using brackets on the inside because we have closed dots on the inside. Alright, so all the solutions have to be greater than or equal to 3, less than or equal to negative 7. Anything in between would not be considered part of the solution set. Alright, so then for number 20, same thing. It's already isolated for us, so make the two cases. 2x plus 5 is less than 6. I'm going to go right ahead and distribute the negative. So if I distribute the negative, we get negative 2x minus 5 is less than 6. Alright, so I just went ahead and distributed the negative. Alright, so then for the first case, you get 2x is less than 1 after you subtract the 5. So after you divide the 2, you get x is less than 1/2. Next case, add the 5, you get 11. Divide by negative 2, it flips the sign, and you get 11, or negative 11 over 2. Alright, so then on the left side we have negative 11 over 2 with an open dot. We got 1/2 on the right side with an open dot. Everything less than 1/2 goes to the left. Everything greater than negative 11 over 2 goes to the right. So in this number line, everything falls in between. So our solution set is parentheses, negative 11 over 2, comma, 1/2. Close parentheses. And again, we're using parentheses because these are open dots. If they were closed, then you would use a bracket. Alright, so then for 21, we got 5x minus 3 is greater than or equal to 9. Alright, so then negative infinity, 5x minus 3 is greater than or equal to 9. I'm going to go ahead and distribute the negative. We get negative 5x plus 3 is greater than or equal to 9. Alright, so then for the first case, we get 5x is greater than or equal to 12. Then x is greater than or equal to 12 over 5. Second case, subtract the 3, you get negative 5x is greater than or equal to 6. Divide the negative 5, you get, divide the negative 5, so that flips the sign. Alright, so then on this side we got negative 6 over 5 with a closed dot. This side we got 12 over 5 also with a closed dot. Alright, all the x values greater than or equal to 12 over 5 are going this way. All the x values less than or equal to negative 6 over 5 are going towards the left side. Alright, so we have a gap in between. So that's going to give us negative infinity to negative 6 over 5, bracket, union, open up with a bracket again, 12 over 5, and it continues going to infinity. Alright, so then for 22, alright, on this one we have to isolate the absolute value, so we have 7 plus, so we're subtracting 7. Alright, so don't get confused. You're not going to divide the 7. You are subtracting 7. If it was 7 times the absolute value, then you would divide by 7. But this is 7 plus, so minus 7 to move it. Here guys, then by looking at the function, this says that an absolute value is greater than negative 6. Since this is a negative number right here, this inequality is always going to be true. Whatever I plug in for x here, the absolute value is always going to be positive, which is always going to be greater than negative 6. So since I could plug in any single x value, any number on the number line, and this is always going to be true, this is going to be all real numbers. Alright, so this is all real numbers because the absolute value is always going to be greater than negative 6. Alright, so next one, 23. Again, we have to isolate, so subtract the 18. Alright, so again, there's a difference. This is 18 plus, and this is 2 times. Alright, so you subtract the 18 first. Alright, so now divide the 2. Alright, so we have the absolute value of x plus 6 is less than or equal to 9. Now make the two cases. X plus 6 is less than or equal to 9. Alright, I'm going to go right ahead and distribute my negative. We get negative x minus 6 is less than or equal to 9. Alright, so then subtract the 6. On the first case, you get 3. Next case, you got negative x is less than or equal to 15. Then divide the negative, which is going to flip the sign. Alright, so everything less than negative 3 is on the left side. Everything greater than or equal to negative 15 is on the right side. So everything falls in between. So our solution set would be from bracket negative 15, comma 3. And then close with a bracket. Alright, so now for number 25. Which of the following pairs of lines describes the equation y equals the absolute value of 2x plus 9? Alright, so if we look at Alright, so if we look at this function, if you were to solve it, you would make two cases, right? You would have The first case is like 2x plus 9 equals, right here, the first case would just be y equals 2x plus 9. The second case would be y equals negative parentheses 2x plus 9, which after you distribute the negative, you get y equals negative 2x minus 9. Alright, so these would be the two cases. So the options that don't have our two cases are option A, that one has negative 2x plus 9. Again, this one has the same thing, so you cross out B. And then C and D, they both have our two options. But now let's look at the graph of the absolute value of 2x plus 9. So it looks like this. It has a vertex at, let's see, so the vertex should be at, alright, so the vertex is at negative 4.5. Also, if we were to graph our two situations separately, our two cases, here we have 2x plus 9 without an absolute value. Then our second case is negative 2x minus 9. Those two lines make our absolute value function. It's just that we don't have this bottom part when we apply the absolute value. So this one right here is the 2x plus 9. If we want to get just that half of the graph, we have to get all the x values that are greater than or equal to the vertex, which was negative 4.5, which is the same as negative 9 over 2. Right, so all the x values have to be greater than or equal to negative 9 over 2 just to get the right side. Now for this line going this way, that one is negative 2x minus 9. It has a y-intercept of negative 9, a slope of negative 2. So if we just want to get that half of the graph, we have to get all the x values, or just get all the values less than or equal to negative 9 over 2. So we would have to change the, we would just look at this half. So everything less than negative 9 over 2, everything greater than negative 9 over 2. So that would be this option right here. Alright, so that one is D. Again, because they both have our two cases, and if you graph the two cases, they make two linear lines, but if we restrict the lines to just to that half, we would have to restrict them this way. Ooh. Yeah, so let me go over that again. I think I was covering it. So here, when you solve an absolute value, you make two cases. We have the positive case, y equals 2x plus 9. You have the negative case, negative parentheses 2x plus 9, but when you distribute the negative, you get negative 2x minus 9. Alright, so then the option that had those two cases was C and D. And then like we talked about here, it has a vertex of negative 9 over 2. If you want to get the right half, the line 2x plus 9 has to be restricted to x greater than or equal to negative 9 over 2, which is the right side. And then for the other line, you have to restrict it to just the left side. Alright, so then for 26. So here on 26, they provided us the pictures. So we got y1 and y2. Alright, so the absolute value function, that's y1, and then y2 is just the horizontal line at 4. Okay, so y2 equals 4, horizontal line. So for A, we have absolute value of x minus 3 is less than or equal to 4. So when is the absolute value less than negative 4? So it's less than right here. Right, that's the only time it's less than y equals 4. So the solution set or set notation for this would be, well, here, let's do the interval notation first. So from negative 1 to, what is that, 1, 2, 3, 4, 5, 6, 7. So from bracket negative 1 to 7, That's where the solution set would be for when the absolute value is less than or equal to 4. Now the set notation would be from -1, less than or equal to x, less than or equal to 7. Alright, so then for b, absolute value of x minus 3 is greater than 4. So when is this greater than 4? So the function right here is greater than 4 on these two branches. That's the only time the function is greater than 4. So the interval notation would be from -infinity to -1, parentheses, since we're just greater than, union, parentheses, 7 is greater than infinity. Alright, so then our solution set would be all the x values on the left side have to be less than -1, or for the right side, all the x values have to be greater than 7. Alright, so that is the end of the review. And don't forget to like and follow.